Have you ever wondered how your operating system, your favorite games, or even the computer in your car actually works? Well, the answer, way more often than you'd think, is a language called C. Today, we're going to dive into this foundational programming language and see why it is still an absolutely critical skill for anyone who wants to write code. So, let's get right into it.
So here's our game plan. We'll kick things off by figuring out why C is basically a superpower in the programming world. Then, we'll pull back the curtain on how your code magically turns into a real program. After that, it's time to get our hands dirty and write our very first C program. We'll also cover how to give your code a memory, make it interactive, and finally we'll wrap up with the whole philosophy of C and where you can go from here.
All right, first up, why on earth is C still such a big deal? I mean, it's a fair question, right? Why would you learn a language that's been around since the 70s? Well, let's find out.
Seriously, with all the shiny new languages popping up every year, why bother with C? The truth is, C's age is actually one of its greatest strengths. It's not just a classic, it's a timeless language that is still incredibly, and I mean incredibly, relevant today.
This table pretty much says it all, doesn't it? C is super fast, like a rocket bike. It's the powerful, efficient foundation for so much of the tech we use every single day, from our operating systems to big-time game engines. And I love this last analogy. Learning C is like learning to ride a bike without training wheels. Once you get it, pretty much every other language is going to feel way easier because you'll understand what the computer is actually doing under the hood.
So let's hop in a time machine for a second. We're going back to the 1970s at Bell Labs. A computer scientist named Ritchie was working on a brand new operating system called Unix. He needed a language that was powerful, but also portable, meaning it could run anywhere. So he just created one. He created C, and it completely revolutionized software development forever.
Okay, so we know why C is so important. Now let's dig into how it all works. We're going to explore that process of turning the text that you write into a program that actually runs. You know, it might seem like magic, but you're about to see that it's a totally logical, step-by-step process.
The best way to think about compiling your code, it's like baking a cake. Seriously. First, the preprocessor is your assistant, gathering all your ingredients. Then the compiler translates your recipe into assembly, a more basic language. After that, the assembler turns that into the raw zeros and ones the computer understands. And finally, the linker sticks it all together to create your final program, your cake. Every step is crucial, and knowing what they do will make you a much better C programmer.
And here's a little cheat sheet that gives you a more technical look at that process. You can see each step actually creates a temporary file along the way. But here's the good news. When you use a simple command like gcc to compile, it does all 4 of these steps for you behind the scenes. It just takes your code and spits out a program you can run.
All right, enough theory. It is time to put this into practice. In this section, we're going to write our very first C program. Let's do this. So to get started, you just need 2 things, a text editor to write your code and a C compiler. For today, to make things super easy, we're going to use a free online tool called OnlineGDB.com. The best part? No installation needed. It's perfect for getting started. So let's head over there right now. Okay, once you've got OnlineGDB open, you'll probably see some code already there. Let's just delete all of that so we can start fresh. On line 1, type this, #include, then in angle brackets, stdio.h. This line basically tells the compiler, hey, we need the standard input and output library, which gives us tools to print stuff to the screen. Next line, int main void. This is the heart of our program. It's where everything starts. Now let's add an opening curly brace. Inside that, we're going to type printf hello world \n. The printf function, you guessed it, prints text. That little \n thing, that's a special character that just means start a new line. Finally, type return 0. This just tells the operating system that our program finished successfully. Add your closing curly brace, and now click that big green run button, and boom, look at the bottom pane. Hello world, you did it. You just wrote and ran your very first C program.
And that's it. That simple block of code is a complete working C program. You've got your library, your main function, a print statement, and a return statement. This is the basic skeleton for pretty much every C program, and it's the foundation for everything else we're going to learn.
Okay, we know how to write a basic program, which is awesome. But now, let's learn how to make it way more useful. In this section, we're going to talk about how to use variables to store and work with information.
So what is a variable? Just think of it like a named container, like a little lunchbox or toy box sitting in your computer's memory. You give it a name, you tell it what kind of stuff it's going to hold, and then you can store all sorts of data in it.
Now you can't just name these little boxes whatever you want. There are a few rules. As you can see here, names can have letters, numbers, and underscores, but they absolutely cannot start with a number. They also can't have spaces or special characters like a hyphen. And a big one, you can't use a word that's already reserved by the C language, like int, as a variable name.
And just like you'd use different boxes for different things in real life, C has different types of variables for different kinds of data. You use an int for whole numbers, a float or a double for numbers with decimal points, and a char for just a single character. Let's see how this works. Back in our OnlineGDB editor, let's create a variable right inside our main function. Go ahead and type int my_age equals 25. So what we've done here is create a variable of type int, we've named it myAge, and we've given it the value 25. Simple, right? Now let's change our printf statement to print it out. Change it to printf myAge is %d\n my_age. That %d is a format specifier. It's like a little placeholder that tells printf, hey, an integer is going to go right here. Okay, let's run it. And look at that! The output now says my age is 25.
So far, our programs have been pretty static, right? They can print things, they can store data, but they can't really interact with a person. Well, in this section, we're going to change all that. We're going to learn how to get input from the user and make our programs truly interactive.
We've already met printf, which is kind of like the storyteller. It lets the computer talk to you. Now let's meet its counterpart, scanf. This is like the robot's ears. It lets you talk to the computer. The single most important, crucial, can't forget it rule with scanf for basic types is you have to use that ampersand symbol, the and, to tell it exactly where in memory to store the user's input. This little table is a super handy reference for using scanf. As you can see, you use a different format specifier for each data type, just like with printf, and you need that ampersand for most of them. The exception is for strings, which are stored in something called an array. We'll get into the why of that later, but for now, just know that's the one exception. Let's see it in action. Okay, in OnlineGDB, let's start fresh again. First, let's declare two variables, int userAge, and then char username 50. That second one creates what's called an array of characters, basically a row of 50 empty boxes in memory to hold a name. Now, let's ask the user for their name with printf, please enter your name. To read their answer, we'll use scanf %s username. See, no ampersand for the string. Next, let's ask for their age. Printf, please enter your age. And we'll listen for it with scanf %d and userAge. And this time, we absolutely need that ampersand. Finally, let's print a personalized message back. Printf, hello, %s, you are %d years old, /n, username, userAge. Okay, let's run it. How cool is that? The program now talks to you, waits for your input, and then uses it to talk back.
We've learned a ton of the how of C programming. Now let's take a step back and talk about the why, the philosophy behind the language. In this last section, we're going to explore what it really means to think like a C programmer.
And to help us get in that mindset, let's look at a quote from Linus Torvalds, the guy who created Linux. He was a huge advocate for C, and he's not shy about his opinions on other languages. This quote really gets to the heart of what makes C so special, so it's a great place for us to start.
So what's he really saying here? Well, for Torvalds, it all comes down to control. He believes C is the best language for system-level stuff because it gives you a clear glass box. You can see and control everything. This is so important when you're building something like an operating system because you need things to be predictable and fast. Languages that act like a mystery black box can hide details from you, which might cause slowdowns or bugs that are almost impossible to track down. C forces you to be disciplined, and that's a huge part of its power.
So, what's next? Your C journey is really just beginning. As you can see, there's a lot more to learn. You'll need to master things like operators for math, if-else statements and loops to control your program's flow, functions, arrays, and eventually, the true superpower of C, pointers. But don't get overwhelmed. Every step builds on the last. For now, let's just focus on practicing what we've learned today.
All right, time for your first challenge. I want you to try and write a program that asks the user for two numbers and then prints out their sum. You've got all the tools you need. You'll use variables, printf, and scanf. Give it a shot, and good luck. And that's it for our introduction to C programming. You've officially taken your first steps into a much larger world, and I am genuinely excited to see what you're going to build. Thanks so much for watching.